Welcome to emitter biasing review. So here is our emitter biasing circuit. It's commonly drawn like this, where we have VCC, RC, our transistor, RE, and minus VE. And RB. So it makes it easier to do the analysis when you draw it like this right here. So it's easier to see the Kirchhoff loops. So whenever I have it set up, drawn like it is on the left in the red, I'll usually just redraw it like it is on the right. Okay, so we can get started here. Let's write our Kirchhoff loop. Here, get our polarities in, plus to minus, plus to minus, plus to minus. So we can rewrite this loop as minus V2 plus VRB plus VBE plus VRE equals 0. So we can rewrite that as VRB plus VRE equals V2 minus VBE. And we know that RB is equal to, or VRB is equal to IB times RB. And VRE is equal to IE times RE. And we're going to subtract V2. Oops. That's equal to V2 minus VBE. Now we know that IE is equal to IB times beta plus 1. Rewrite that in terms of IB. Now we can factor out the IBs. And we can solve for IB. There it is. I can solve for IC. IC equals IB times beta. I can solve for IE. IE equals IB times beta plus 1. Now I can find VRB. IB times RB. I can find VRC. IC times RC. I can find VRE. IE times RE is equal to VRE. And now I can do Kirchhoff loop to solve for VCE. I'm going to write my Kirchhoff loop right here. Put in my polarities. So I've got minus V2 minus V1 plus VRC plus VCE plus VRE equals 0. So we can see that VCE is equal to V2 plus V1 minus VRC minus VRE. I know my cutoff voltage, VCE cut, that's going to be equal to V1 plus V2. I know that my saturation current is going to be equal to IC sat, and that's going to be equal to V1 plus V2 divided by RC plus RE. So we're imagining that transistor is shorted. And I know my Q point here, VCE, comma, IC. Okay, so now I'm looking for VB, VC, comma, and VE. And let's put our polarities in. We can see that VB and all these voltages are referenced to ground right here. So VB is equal to, if I put my probe right here on the base, and I go Kirchhoff towards ground, I've got minus VRB. VC is here, And I can Kirchhoff this way, or I can Kirchhoff this way. And that's equal to, and both those values should give me the same exact VC. So that's equal to minus VRC plus V1, or plus VCE plus VRE minus V2. Okay. The last one we need to do is VE. VE, we can do the same thing. We put a probe right here on the emitter, and we can Kirchhoff up through VCE and around to ground, or we can Kirchhoff up through VBE and over through RBE and to ground, or we can go straight down through RE up through V2. And all those values should be the same number. So we're going to do plus VRE minus V2, or minus VBE minus VRB, or minus VCE minus VRC plus V1. All right, so now the question is PQ1. And PQ1 is equal to VCE times IC. So the power of the transistor is equal to the voltage collector to emitter times the collector current.